Friends, as promised, we are back again. So, in the previous video, where we did not conclude, but we actually referred to part two of this data presentation, we had discussed that there are certain examples where graphical displays should not be used. And so, here we will be discussing some such examples from the collected from the research papers and reports issued by other authors, while from where we have taken up these examples. So let us have a look at some such examples. Let us look at this. Now, this is an example of a data set where there is over dispersed values. What I mean to say is that you see there are 8 faculties. Say in an university, there are 8 faculties or a department, there are 8 faculties, and I am trying to display the number of publications, books published by these faculty members through a graph. Now, you can see faculty number 1 has published or authored 3 books, faculty number 2 has published 7 books, and so on. Now, faculty number 6, now that particular faculty might be in the habit of publishing from his very inception, maybe from his college days itself, he is publishing. And now, at this end of his career, he has completed 77 published books. Now, first thing is that whenever you come across such data set, it is very important to look into or scrutinize the data and revisit that particular data source and find out whether this is really a possibility or not. Because while others are publishing at the max of 11 books, one of them is publishing 7 times more than that. There is 77 books, so 7 times more than the next maximum. Now, this is improbable, but not impossible. Might be. There are some people who are prolific writer, have been writing books from the very, say, younger days, and might be by this time has completed publishing 77 books. So first thing is that you scrutinize, you go back to faculty number 6 and check his titles, etc. So once you are satisfied, now you are going to display the data or present the data somewhere. Now, for these graphical tools or any graphical tool is not good enough, because he is much, this value 77 is much over dispersed. It is an outlier compared to the other values, and look, your graph looks so awkward, and the actually other values like 11, 9, 7, 3, they seem to be coming very close to each other because one of the value is so large. So in such cases, it is better not to go or not to represent such over dispersed data through graphical tools. Okay, now let us look at this. India, I remember that in our younger days when we were studying in the school, India did not get any such medal in Olympic Games. Last time they got was in 1980, and then that also in hockey. That was a team event, and after that, for quite some time, India did not get any medal, either not even bronze. Then times started to change in the early part of this millennium. India started to get some medals, and their best performance so far, though they could not get any gold, but their best performance till 2000 was in the 2012 Olympics, which was played in London, and many players, as many as 6 of them, got different medals. Unfortunately, India did not get any gold, but India got 2 silver and 4 bronze medal. And in any particular Olympic Games, this was the maximum number of medals that India has got. That is 6. Rank-wise might be because of absence of gold, they were down the order. But then anyways, they got sufficient number of medals compared to the other Olympics. So now you want to represent that it is in a graph. Now this is not a thing which you represent by graph. Rather, it is better to express it in text, because you have only 2 values: silver 2, bronze 4, and gold has no score for gold. So if you represent it in a graphical way, it looks so odd. First thing is that very vividly it expresses that there was no gold. And so whenever there is some such few observations only, which can be very well summarized through a text, it is better not to present them in a graph, because graph takes more space. A graph needs to communicate the complicated information, but here the information itself is very simple. And so expressing it through a graph is not at all a good proposition. We move forward and then we have next. This is a interesting presentation. Actually, this is a graphical tool taken from a paper on cricket analytics. And here, the researcher wanted to find out who is the best all-rounder or who are the very good all-rounders. So he actually classified in the x-axis, that is this axis, he has taken along this axis, he has taken the strike rate. That means betting strike rate. This is strike rate. How it is computed? Number of runs scored per ball. So number of runs scored. Suppose I have scored 30 runs in 15 balls. So runs scored will be 30. Balls faced will be 15 multiplied by 100. So my strike rate will become 200, which is quite high. So this is taken from this data is taken from IPL 2008. That is the first IPL 2008. And this side, the author has placed strike rate of the all-rounder, betting strike rate, and this side in y-axis, economy rate of the batsman all-rounder was considered. Means when he went for bowling, that particular bowler, what was the economy rate? And when he went for betting for that particular all-rounder, what was the strike rate? Now, what we want? We want that a bowler should be very good. That means his economy rate should be low. But when he goes for betting, he should have a high strike rate, means ideal situation. That means he scores run with a very high pace. So in that case, what happens? So the strike rate should be high. That means now as you move from this side to this side, as you move from this side to this side, the strike rate increases. And as you move from this top to bottom, the economy rate decreases. So traditionally, I want a high strike rate and a low economy rate. That means the all-rounders who actually appear in this part has high strike rate. This particular quadrant has high strike rate but low economy rate. They are considered as good all-rounders. We name them, or means the author has named them as performer. Now here, the people who are placed here, means this is actually a scatter diagram, and then we have given the name of the player who represents the dot. Now the player who comes up here is having a good strike rate, but economy rate not so good. That means that person is a betting all-rounder. Jayasuriya, Simons, Hasi, Hopes. You also have Yuvraj Singh here. So they are very good at betting, but not so good while they go for bowling. Now, this is one where we have the bowling all-rounder. Means when they bowl, they have a low economy rate, but their strike rate is not that good. Means while they go for betting, they cannot score runs at a very high pace, but their economy rate is good. So bowling all-rounder, so they are placed here. You can find Saurav Ganguly here. Saurav Ganguly is generally a batsman, but in IPL 2008, his performance was not so good as a batsman, but he was a good bowler. So he had a lower economy rate, but not a good betting strike rate. So, and these are the underperformers. When they bowl, they have a very high economy rate, and when they bat, they could not score runs very fast. So this is the place where no one comes or no one should come, but many players are there. Even you can see Virat Kohli coming up here, because in that IPL 2008, Virat Kohli was very young and he did not become the Virat Kohli you know today. Anyways, he had a poor economy rate and also a poor betting strike rate. So he has come under underperformer. So this is how this graph interprets. Now the person has made a table also and shown the graph also. Now you see, graph becomes so clumsy because simply dot would make it look nice, but simply dot will not help you to identify the player. So the text should come with the dot. So you cannot have this dot in isolation, but along with this text is necessary. Now this graph looks very clumsy, very dirty, and now it is looking further dirty because of my marks anyway. Let me remove my marks and try. Now you tell me whether really it looks nice. I have taken all my marks. Yes, I can take enough all my marks. And now, yeah, even then it's quite clumsy. Rather than that, if I use this table, by the side, you see the table, same information is placed in the table. You see who are the betting all-rounders, you find who are the performers, you understand who are the bowling all-rounders, and you know that who are the underperformers very clearly from the table. So next time when you go for IPL auction, you are not to consider the underperformers. So that is one takeaway. So underperformance, you not to compare. Strangely, Virat Kohli has also come in this list, but it was in 2008. have to remember, at least 20 years, almost 20 years earlier. Anyway, so this is what but you see Rohit Sharma used to bat also, bowl also at that time. Initially, he used to come as a change bowler and bowl a few overs through. He had a good economy rate, and so he has come under a performer. So this is what we find out. So what I meant to say that many a times too many values with lot of text or lot of data labels makes the graph clumsy, and sometimes tabular representation comes better than a graphical tool. Most important thing when you present a data is to see that the presentation looks decent. Unfortunately, this graph is not so decent. Anyways, let us move forward. Do's and don'ts of charting. That means when you prepare a chart, what things you have to keep in mind and what things you should always try to avoid. Now, this is a graph where corresponding to different years, as you can see here, the different years are here. And this is probably a company, total sale of all the companies. Okay. Total R&D expenditure. So research and development expenditure and these are the total sale of the companies. So I want to have this graph. So when I have this graph, you can see that the graph appears in this form. Now, what is the problem in this graph is that I have, well, sale in crores and R&D expenditure, and you can see that as sale increases, the expenditure also increases. Okay, this is giving you a nice view of this. But the problem is that you see some space remains empty in this graph. This area is useless. It is not used up here. Now, what I can do is that you see this axis starts from 0. This your x-axis. Obviously, y-axis also starts from 0. But you have some smaller values as well, but not so much in case of x-axis because your value, minimum value is more than 50,000. No, 5 lakhs. Minimum value is more than 5 lakhs. I think this is the minimum value. Yeah, 5 lakhs. Yes, minimum value is more than 5 lakhs. So unnecessarily we keep this space here and we do not get any point here. So what I can do is that I can adjust the axis little bit. See, this we select the axis. We have this graph. We select, click on the x-axis, uh, left click, and then we right click on it. Then we get this. There is an option called as format axis which comes up in Excel. So using format axis, when we click on the format axis, we get a table like this. And in the table, there is an option, axis option. So there is an auto and there is a maximum, minimum, maximum. So it has taken the automatic value, automatically it has taken. So what I can do is that I can fix the value. So I fix the value here at 50,000, fix the value here as 50,000 because not 50,000, sorry, 5 lakh. 5 lakhs, so that I can start the graph from 5 lakh itself. And then we go to close. And now you see the expenditure here instead of 0, it starts from 5 lakhs. And so the points have come up throughout the graph and there is no gap at the beginning. Similarly, here I think last value is 20,000, 20 lakhs. So unnecessarily no point of going up to 25 lakhs. Similarly, you can adjust the axis, start from 5 lakh and at 20 lakh and get a reasonably good graph where the points are scattered throughout the graph and there is no empty space in the right or the left, so that you can represent the data in reasonably smaller size without wasting blank space inside the graph. So this is one good practice that you should follow by adjusting the axis, especially when you use graph for representing either in a report or more specifically when you represent it in a PowerPoint presentation, so that these unnecessary spaces are overcome and the attention of the people are towards the points which are all through spread out in the graph from top to bottom. Okay, this is an example from a company. Say several companies are there. We have their sale data. We have the data related to their expenditure and we have profit. Profit is obviously sale minus expenditure. We are getting the profit. Now we want to represent them in a graph. Now here you see we have three variables which you represent in one single graph. These variables, though they are measured in some currency notes, but they will have different ranges. Obviously, their range will be different because sale you cannot directly compare with expenditure. So the range of sale will be different, expenditure will be different, profit will be different. But then obviously they have the same unit of measure. Now we want to see whether a sale has some relationship with profit, everything we want to see. We want to see the relation between sale and expenditure also. Issue is that if there are two variables, sale and expenditure, we can represent it by a scatter diagram. But since we have three variables and each of them are important and we want to display all of them. So basically we are to represent three variables in a two-dimensional plane. So this is actually 3D visualization, but we don't want to go for a 3D. We have seen uh, or we'll see in future that when we visualize two-dimensional data in a three-dimensional plane, it might be quite difficult and complicated to understand. In this regard, we want to utilize the concept of two dimension, but even then representing three dimension. A good example to do this is called as a bubble chart. A bubble chart is less in use, but is very useful for representing three variables in one single graph. So actually we select the data, then if we go to insert and then we go to say recommended chart, then we cannot find a bubble plot here. Yes, it is giving me recommendation of a bubble plot. So well, I can have it like this. So I can have it bubble plot here and then I can go with OK. Now we get the bubble plot, but before we actually use it, we need to make some changes. We actually try to increase little bit of the visualization, zoom little bit. Okay, first let us represent this and replace this. Okay, delete this. Now once again you see axis starting from 0 to 10,000, so it is creating some blank space here. So I can adjust this axis. So I can format this axis and start from 10 lakh. 1, 5 zeros, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just press tab, it will get adjusted. So it has got adjusted now. Now let me introduce this. Let me introduce an x-axis title, y-axis title, because so many variables are there. It has shown some negative values also because one of the bubble is coming out. Now I'll understand. We'll understand what is this bubble. First, along the x-axis, axis title. Along the x-axis, what is represent? Sale is represent. So I can have here sale in rupees. This y-axis, this is the expenditure. Expenditure, and the size of the bubble represents profit. From here you can make out that bigger bubbles means higher profit. Also you can watch one thing very interesting, that bubbles are automatically kept transparent, or rather you can tell translucent, so that we can see what is happening behind the bubble as well. So this bubble is quite separate, and you see size of the bubble represents the profit. Those with bigger size means higher profit. And you will see that these three bubbles have very less sale, and so their profit is also less. So one way to increase profit is to increase the sale, because the size of the bubble represents the profit. Here expenditure is less. If a bubble goes up means expenditure high. For example, this one, this particular bubble, which is, if you click outside, keep the mouse here, you will find that which one. It is 452066. So 452066. 2066, that is this particular company is here. So this company, they are having very high sale, simultaneously they are having very high profit, and they are also having very high expenditure. But if you look at this, they are having high sale because they are towards y-axis, they are going to in one side, on the right side of y-axis, increasing their sale is quite high. And big bubble indicating high profit, but their expenditure, that is their position along the y-axis, is relatively in a lower end. That means expenditure is less. This is probably the ideal situation, that your sale is good, moderately good. Maximum, I think here is the sale. This 1, 2, 3, 4, 5. These 5 companies are having high sale. This is having moderately high sale, but having a huge profit, and expenditure is minimized. So this is I think this is the best of the lot, because having a high expenditure is not good, though you might have a high profit as well. So here you see these bubbles are lesser in size than this one. Another big bubble is this. This is also having a high profit, but they are having high sale, low expenditure, high profit. So from this we can understand that if a company wants to have more profit, they need to, number one, they need to increase their sale. Number two, they need to decrease their expenditure, and then the profit will be high. So this way we can represent a three-dimensional uh, data set in a two-dimensional plane without having the effect of the curse of dimensionality. In the subsequent presentation, in the same this presentation only, we will see cases where people are making a math in representing a two-dimensional variable or with the help of three-dimensional figures. But here you see three-dimensional data is there, but we are representing them very handsomely and very meaningfully in a two-dimensional plane. And as soon as the graph is drawn, we can also understand the interrelationship between the variables, that is sale, expenditure, and profit. Okay, now let us look at this. How, with the help of adjusting the axis, we can do the comparison. Now, these are the data. Say there are 6 faculties in an institute, and this is the order in which they have published the books. Not the order, number of which they actually in the last 5 years, number of papers published in research journals. So faculty number 1 has published 14 research papers. Faculty 2 has published 16 research papers. Faculty 3 13, faculty 4 12, faculty 5 17, and faculty 6 15. So this is the way in which they have published the research papers. Now, here you see, if you look at the data set, means all the research, all the faculties have published more than 10 research papers. That means there is no point on showing the data less than 10, because everyone has at least 10 papers. So instead of taking the axis from 0 to y-axis, from 0 to 18, because 18 is good because highest number is 70. And so whenever you put this data in Excel by default takes this as 0. Upper one, it adjusts very nicely, like it has got the maximum as 17, it has actually plotted the 18. So far as upper limit is concerned, Excel is very smart. But Excel is not very smart in controlling the lower limit. It generally has a tendency to start from 0. So it starts from 0, goes up to 18. So till this level, there is no one who completes it, because they all have more number of research papers than now 10. Now, if we adjust axis using the same process, we first we click on this axis, left click, after that we right click, and then there is an option comes up, format axis. So if you click on that format axis, then it shows a table which shows maximum, low and minimum for y-axis. So maximum you can take as upper limit. Maximum means upper limit. Upper limit is okay. You don't no need to touch it. But minimum, it is the lower limit. Instead of starting from 0, you can start from 10. As soon as we start from 10 and as soon as we plot it, we get this graph. Now you may tell that, well, both the graphs actually communicate similar type of information. So what is the point on actually changing the axis? Now you see here, if you look at this graph, then you see that here the graph starts from 10 goes up to 14, 10 goes up to 16, 10 goes up to 13, 10 goes up to 12, 10 goes up to 17, 10 to 15. That means no one has missed, because all of them have got more than 10 publications. But here you see the variability in the bars. Here if you look at this, they are more or less uniform. Means there is not much variation. It seems that there is not much variation. Values have remained the same, but look at the visual appeal. All of them are ending up in this circle. But here you see, they are going up like this, coming down, and then going up, then coming down. So there is a huge difference. And so here easily you can identify that, okay, faculty number 4 has a minimum number of publications, and faculty number 5 has a maximum number of publications. So well, the faculties are, there is a difference between the faculties. That means small difference can now be very vividly expressed. So first thing that you have to do with a graph is that need to communicate to the viewer. The viewer should be communicated and communicated correctly. Now, in the previous previous graph, they seem to be more or less uniform. Here the difference comes up. So difference can move, means the second graph seems to be more sensitive than what is the first graph express. So this is an important aspect which you have to remember while you do charting. Next, let us go to another example. Now, same example. Now, here I went with the faculty numbers. I arranged it as faculty 1, faculty 2, faculty 3, faculty 4, faculty 5, faculty 6. Now, I have done this. Now, when I plot it, I get this one. This way, then increase, then decrease, then increase, and decrease. Now, this is not a timeline. This is just publication of some individuals across a particular time period. This is not a timeline that there is no continuity in the system. They are not continuous. That are all discrete. So you cannot imagine a line like this. It does not have any meaning. I saw some presentation where they are representing something like this publication with the help of a line diagram. These are the faculties and then they are drawing line. How strange. They are doing like this, that they are not drawing the bars. They are rather drawing a line, well, like this, then this, okay, then like this. They are drawing a line diagram. Now, line diagram comes only if your x-axis is containing. This is your x-axis. X-axis. X-axis is containing something which is continuous in nature. Now, these are not continuous. These are individuals, and we want to show the frequencies, that is publications, some count data corresponding to different faculties. So, first thing is that this is not at all recommended line diagram. The bar is good. I don't have any complaint with the bar as such for representing this. Okay. Now, what happens here? If I arrange them in an order, like here I have arranged, you see faculty numbers in haphazard. They are not like faculty 1. I am starting with faculty 3, 4, then faculty 3, then faculty 1, then faculty 6, then faculty 2, and faculty 5. You may think that, okay, what is happening? Why the faculty are so haphazard? And look at the publication, starting with 12, 13, 14, 15, 16, 17. You can have the reverse also, starting from the maximum and going to the minimum. Now, this actually help you to find out very easily, okay, faculty 5 is having maximum publication. Who is having minimum publication? Faculty 4. So this is actually very nicely readable. This is very nicely readable. So one way of dealing with this type of data is that it is very much readable. Easily, person can understand what is the way in which easily information is collected from this. Okay. Now, one thing you see, is there any other way? Because whenever you want to represent some frequencies, you draw the bar diagram. Now, these days, the day of visualization, whether you are in business research or any other type of research, even for a popular article, forget the research article, even for a popular article, people look forward these days for new type of visualization. Now, new type of visualization, what we can do with this type of data, you may, because this is the day of artificial intelligence, people have any doubt in their mind regarding to anything, the one thing that they do is called as the, just ask a question to any of the artificial intelligence tool to which you are, your favorite artificial intelligence tool. You ask the question that I have this type of data, I don't want to represent them by a bar diagram, please suggest some other types of diagrams. And sometimes they provide the code also, that this is the Python code or this is the R code with the help of which you can draw it. Unfortunately, all of us don't have access to or are expert in programming, so sometimes it is difficult, but they may also suggest you. First thing is that when you want to chart, there are several internet resources which you may try to find out, where actually you can draw a graph for user defined data. You can get different types of graphs there for drawing this type of, you have the data drawing this graph. Now, one thing is that which is called as the data ink ratio. What is data ink ratio? Ink ratio. Data ink ratio is the number of data points you represented. Okay, sorry. It is the number of data points you represent divided by the ink you actually spent in drawing the graph. Amount of ink you spent in drawing the particular graph. Say these data points, how many data points? 1, 2, 3, 4, 5, 6. So data points are 6 in number. How much ink you used? So you just find the area of this rectangle, this rectangle, this rectangle. Just find, simple to find the area, length into breadth. Say this is 1 unit and this is, say, how much it has gone? 5. And if this is say about 14 units, so 14 into 1, 14. So this way you can find out the area of these small rectangles. So that area say comes out to be 75. Now this is becoming very small quantity. Now as the data ink ratio becomes small, it is not a good one. That means you are using, uh, you have a very small amount of data. You are spending lot of ink in drawing this. But suppose I spend very small amount of ink. Okay, suppose I draw this graph in this way that I actually have this. I have a point here 14. I have a point here 16. Have a point here 13. I have a point here 12. I have a point here 17. I have a point here 15. And then instead of drawing this bar, I actually connect this by a line because I cannot, sorry, it should be a straight line. My hands are not going straight. Oh, sorry for this inconvenience cost. Okay, so this. Now, these are the, I don't draw the bars. I don't draw the bars. Now you see with very little ink, I am representing the 6 points. So that means the expenditure I am making in ink has decreased significantly. Say now the area of the or amount of ink earlier if it was 75, now it becomes 7. So now this becomes very close to 1, close to 1, tends to 1. 6 by 7 is very close to 1. That means earlier it was very small, now it has grown significantly. So this will be considered as a good chart compared to what was drawn earlier. That is compared to this type of graph. This one and this one I have seen of late someone was using this graph. And they have given name also. They call it lollipop chart. Lollipop chart. Lollipop chart. So they are now drawing it with lesser type of ink. So sometimes you may experiment with such things and try to find out if you are a good programmer. Definitely it will be a just a cakewalk for you. But if you are not a programmer, but then some people keep on playing with Excel and can generate this type of graph, and you can take the help of some of the Photoshop type of where you can actually play with photo to generate some graph and get it done in some other way. So there, and if you go study the literature, many people are working on that area of how to represent a data set spending lesser ink, that is with an improved data ink ratio. So data ink ratio needs to be improved. So this is one important takeaway from this particular slide. Let us go to the next slide. Now you see, this is a pie diagram. There are different sectors and these sectors are represented expenditure. Total expenditure, I think 35 plus 25. So that is coming out to be 60. So this is 60 and this is 73. Then this is 17. So this is 90. This is 0, 90. Yes, 100%. So, well, okay. So the total 100%, total I can write here 100%. These are divided. 6 sectors are there in that particular organization. 1, 2, 3, 4, 5, 6. And these are the components expressed in percentage. So there is data set is good. There is no issues. Now you know that for representing this type of diagrams, you may actually draw the bar diagram also. But if you want to compare the components, then one good technique of drawing this graph so far as components are concerned is the pie diagram. Now in Excel, you will find that there are several types of 3D graphs as comes up as an option. And if you ask for recommendation that I have these data, you have seen in the previous day that in Excel there is an option of getting recommended. And in the from Office 2016 onwards, they give you a recommendation. You select the data and click on recommend chart, then they will give you some recommendation that these charts you can use for your data. And if you are predetermined, you know what type of graph you need to draw, then fine, you can go on with this. So a option of drawing this graph is definitely the pie diagram. So pie diagram, the general pie is available, which is circular, divided into components, but a 3D pie is also available here. Now, similarly, also you'll find in case of bar diagram, also there are some 3D bars available. Now, this is not at all recommended. You may tell that it looks nice because graph is also about making things look beautiful. And you told that graph should be presented in such a way that the first and foremost thing is that it should look attractive. I don't disagree with that. I still tell that it should not be attractive, but not at the cost of wrong information. Why I am telling that wrong information? Now here you see this particular, for example, in this graph, let me take okay, this one white so that I can put a mark here. Now this dark blue area, this is not a part of the graph. When this one, sector 1, 35 is drawn with this is the area, which is actually the author is telling about, or the means this is 35%. This is not 35%. This does not contribute towards 35%. But this is a shade which is created. This looks the values which are towards you, because this is actually what? A two-dimensional plane. You look at a computer screen, it's a two-dimensional plane. Oh, okay, I cannot write because the color is white. Okay, oh, I have missed the cursor also. Okay. What is the problem of using? Okay, here is my. Sorry, you see what is the problem of. Better to take yellow, at least you can see it somewhere. Yellow is also not visible. Okay, back to this. Okay, anyways. So what happens here? Here, this part is not actually a part of what data, what is being displayed. This is just a shade created. So those part of the pies, those pies which are facing towards you, those will have this shade. Others have the shade, but they're not so much visible. You can see the shade here. You can see some shade here, but the background of that, the shade is in the other side. Actually, this is a two-dimensional plane, two-dimension, 2D. Computer screen, 2D. Page of piece of paper, 2D. But the figure is a 3D figure. So you are trying to actually replace or draw a 3D figure in a 2D plane. Now we draw face of someone. We okay, let us look at this. We are drawing the face of someone. Okay, this is now obviously a three-dimensional figure, but we are trying to draw in a two-dimensional plane. We are actually accustomed to it, so we don't feel that much. We understand, okay, this is the human face. Yeah. But human face is three-dimensional. You are trying to draw it in a two-dimensional plane. We are accustomed to it, so we get adjusted. Similarly, this pie, but this pie with comes with some accessories which is actually useless, like this part of the pie. Now, what strange you see, this is 0. So actually, there should not be any representation of this in the graph, because this is not contributing at all. But look at this, it has taken a slice. It has taken a slice. Actually, this is the shade of 0. Now, 0 means not there at all. It is not contributed. For some reason, this sector 5 is not at all operational in that particular organization. So it should not create a shade, but it has created a shade. That is a problem with having a three-dimensional diagram in a two-dimensional plane. So never draw two-dimensional diagrams with a three-dimensional view. This actually mars your presentation. It may look nice, but it is completely erroneous, because it is going to show you something which does not exist at all. And this is a wonderful example for that. So having said all this, let us now put the question that whether we want to go for a bar or a pie in this type of things where you want to divide by the sector. Now you see here, I have drawn a normal pie with this. So this is not a three-dimensional, rather this is a two-dimensional pie, and these are the expenditures. So which I have drawn in graph. You can understand, okay, sector 3 has minimum expenditure, sector 1 has maximum expenditure. You can understand in the graph very nicely. But do you understand this in the pie diagram? If you look at the pie diagram, here what happened, the data value are taken in such a way that you see this is something around, I think it is 14. And the maximum value I think is 17. So 14, I think this is 15, 16, 17, 18, maybe this is 19. Okay, this was 19. Sorry, 19. Now these values are actually differing by only one unity. Let me. 14. But when I draw them in a bar, you can easily understand. And also I have put them in an order so that I can just point out at your eyes and show that this is what is happening, and this is how things are differing from each other by a very small margin, but there is a difference. But when you look at the pie, you cannot differentiate it. You cannot differentiate at all. Sector 1, okay, you may tell that, okay, sector 1 seems to be little bigger than the others, but others, and I think sector this one, this is sector 2, this sector 1. So this one, well, maybe little bit smaller than others, but other things are confusing. Like this, and this seems to be of same size. Little bit you understand that this is bigger and this pie is little smaller than others, but it definitely create confusion. You can take this test to some school boys and check out whether they can read the data from the pie and from the bar. You can take an exercise where they can tell in a bar whether which one is more, which one is less, and whether they can do the same thing in the pie. Both the bar and the pie are drawn with the same data values, same observations, but you see the illusion that pi is creating. Not illusion, we can call it non-readability of the data from the graph. The graph should give you an opportunity to read the data from it. Why we are drawing the graph? We are drawing the graph because we want to represent the data. We want to give a pictorial presentation of the data. Having the picture is not good enough. From the picture, we need to read the data. We need to compare the sectors. We want to compare the components, and we can identify spatial observation, etc., etc. But unfortunately, the bar and the pi, which are competitive to each other, many cases the pi may not figure as good as the bar. However, if you want to show the components of the total, the sum total is there, you want to show the components, then you can do this type of uh, pie chart can be used. But once again, if you want to compare the sectors where the values of the sectors are very close to each other, so better to go with a bar, because as I tell, the readability of the data from the graph is a very important factor. All these presentations actually are based on some studies which are this is a very first one is a very interesting book, Writing and Presenting Scientific Papers. Means whenever if you want to prepare any report, not necessarily only to science, but anything which is objective, any report which is objective, maybe a newspaper article, then this book is a very handy and small book, but very useful, and with lot of examples it is. This United Nations 2009 Making Data Meaningful Guide to Presenting Statistics. This is a online document, so you can use this link to search this document. This is wonderful example. It has so many counter examples. How data, how graph can mislead you to understand wrong things. And this is 5 tips for better data presentation. The author's name is not there, unfortunately, but this is a good presentation on this. There are so many other works which has been consulted, but these are the main works on which this particular video is based. So I thank you for attending this particular two versions or two parts of this presentation on data presentation. Thanks a lot. See you soon.